All right. So, welcome to this video. In this next video, we are focused on the concept of differentiability, and we need to determine whether a function is differentiable. All right. So, a function f of x is differentiable at x equals to c if and only if it then satisfies the two conditions. So, first of all, f needs to be continuous at x equals to c, and second of all, the limit of the derivative of f of x needs to exist. If these two conditions are satisfied, we can happily say that a function is differentiable. Let us start by doing the example. Let us look, is g of x differentiable at x equals to 1? So this is what g of x is. So the first thing we will do, we will check for continuity. So we'll check if a function is continuous, so continuity. So that's what we'll check for first. How do we go about that again? So we'll check if the limit as x tends to 1 from the left of f of x, so of g of x, the function we will meet up is that one over there, x plus 4, and then in putting our limit, we'll just plug in what 1 is there, x squared plus 4, and we can easily get that equals to 5. So we can see what the left limit is. Let's check what the right limit is. So the limit is x tends to 1 from the right. We will now bump into the second function there, which is 2x plus 3. And therefore, we can then substitute 1 there and get plus 3. So we know that the limit exists. The limit does exist. So you can see that. So let's check what f of 1 is. So f of 1 is equivalent, because it is less or equals to, we can sub it into this equation. So this becomes x squared plus 1, which is equals to 5. And therefore, in this case, we can say that the limit as x tends to 1 of f of x is equals to the limit to f of 1. So because everything does give us 5. So therefore, we say that f is continuous at a. So very important for us to note that this continuous at x is equals to 1. So now the second condition, now that we are done with the first condition of continuity, let's check if we can satisfy the second condition, which is differentiability. So that's what we need to check. We need to check if the limit exists of the derivative. Okay. So now the way we'll do this, we'll go the limit as x tends to 1 from the left, but now of the derivative of g of x, which is very important. And let's just substitute what the derivative is. The limit as x tends to 1 from the left. The derivative of x squared plus 4 is 2x. And if we substitute 1 there, we get that the answer is 2. So let's now try the right limit. So the limit as x tends to 1 from the right of the derivative. So the derivative of that function will just be 2, and therefore its limit is equals to 2. So now we can clearly see that the limit as x tends to 1, both from the left and the right, it does exist. So the limit exists. So therefore, if the limit exists, we say that the function g in this case is therefore differentiable. Differentiable at x is equals to 1. Nice and simple. You just have to make sure that these two conditions hold. Let's do one last question. So let us look at this next one. Is this function differentiable at x minus 2? So first we have to check for continuity. That's what we need to do first. We need to check if this function is continuous. And we can do that quickly by going the limit as x tends to negative 1, negative 2 from the left. The function we meet up is x squared minus 1. And if we substitute what we need to substitute quite quickly, we can simply work that out. We substitute minus 2 squared minus 1, and we can clearly see that gives us 3. We can then check the limit from the right. So the limit as x tends to minus 2 from the right, that just gives us 3. So the answer is 3. And because of that as well, we can say that f of 3 is, or f of negative 2 is 3. So we could easily say that f is continuous now at x equals to negative 2. So quite important for us to note that. it is continuous at x is equals to -2. Let's check the differentiability bit now. So here we will take the limit as x tends to -2 from the left, but now the derivative of that is 2x, and therefore if we substitute -2, so we will get 2 times -2, we get -4. Let's check the right hand limit. So the limit as x tends to -2 from the right of the derivative. The derivative of 3, however, is 0. So therefore that is 0. So clearly from here, we can see that the limit of the derivative does not exist. So we say that the limit as x tends to -2 of f of x, of the derivative of f of x, does not exist. So if this does not exist, then the function cannot be differentiable there. And that's the difference between these two questions. So therefore we say that f is not differentiable. So make sure that you are able to do all of that. It's not differentiable at x equals to -2. I hope this has made sense. We've done an example where the function is differentiable and where it's not differentiable. In the next set of videos, I'll be doing some miscellaneous equations involving differentiability. I hope this has made sense, and therefore I'll see you in the next video.